So I know you're all eager to hear what are those new features, so let's get started. First up, Marvin.js. So our focus through the last year with Marvin.js has been increasing chemical awareness and having even more comfortable, even faster editing. So first up, we have R groups. So over the last year, we introduced full support for R groups, R group attachment points, homology groups, and now we have this fancy new R group, smart R group tool, which in one tool includes all the editing features you need to assign and create R groups. Next one is reactions. So again, over the course of last year, we added full support for reactions with manual and automatic mapping of atoms, electron flow errors, and again, a smart reaction tool that in a single tool contains the arrow and the plus sign, so you can set the reagents and products for a reaction very, very easily. And now for those working with query structures, just over the course of the last few weeks, we added support for atom and bond properties in the right-click option, where you can set things like aromaticity, implicit hydrogens, ring counts, whatnot. And as for comfortable editing, what we were working on is making sure that you can paste anything from anywhere into Marvin.js, and that now includes ChemDraw with the latest version of ChemDraw if you copy as mol. But it's not just chemical file formats. So you can paste literally any representation of a chemical structure, be that the systematic name, Cas number, INCHI, literally anything. You can drag and drop binary files as well. So you can get started very easily. And now if you're an integrator, a developer, and you have this new view in your application where you know the chemist who drew a reaction or a query structure or an R group, a structure full of R groups, then we have these fit-to-purpose toolbar presets. So you can say the user will now draw a reaction, and we will hide all the useless buttons and just show the ones you need for reactions. So it's very, very cool. Next up, we have Markush structures. So in May, we launched the Markush editor for IP experts, combinatorial chemists. And the purpose of Markush editor is to help draw these complex Markush structures. So this is just like a sneak preview because there will be a full presentation about it tomorrow morning. But basically, you have this hierarchical representation for the fragments of the Markush structure. We also put structure checker there for manual revision and quality of the Markush structure. And it comes as a desktop application and as an integratable component. And we will show one very, very cool use of this as an integratable component later on. Still going to bigger structures, we have biomolecules. So as Doug and Alex mentioned, we are working on this novel technology stack, which will enable storing, searching, standardizing biomolecules. And the primary visualization component we have is the Helm editor, the open source Helm editor. And really our goal here is to create this really nice whole backend and then integrate it into all of our core products to increase their scientific relevance. Again, about this, we will have a separate presentation as well tomorrow, I guess afternoon, by Roland. So this is about, drawing structures, drawing various kinds of structures. But what about when you already have it and just want to load it into an application? So the good thing for us is that that's not a question. Every single one of our applications supports every single one of the chemical file formats. So it can come from any vendor. It can be SDF, SKC, CDX, anything. We can also work with other representations, IPAC names, INCHI, common names. And it doesn't just have to be these explicit structures. It can be reactions, R group structures. What if it's not a chemical structure file? So what if you're working with Excel? So in May, we introduced a migration tool for Record for Excel because it's going out of support. And with that, what you can do is, if you have like this Record for Excel document, then with like a standalone tool, a right-click option, a ribbon action, all kinds of accessibility there, you can turn it into a JChem for Excel document. Done. Another very cool thing that we've done we've done with JChem for Excel is that for various technical reasons around the Microsoft technology stack, we had these 3 different copy tools. So we had one that can copy single structure, we had one that can copy multiple structures, we had one that can copy multiple structures with data and formatting and everything. Well, now we just have one copy button. So we can decide that for you. You don't have to remember the exact use cases for each. So what if you have even more data? Well, we have JChem for Office, which can directly import data from any kind of database. And we have Instant JChem, our database manager tool. So these two can handle most of the data. If you have even more than that, if you need like a bigger migration, then we have consultancy services. They can help you migrate the data to either of these applications. So that's about chemical data that you can find in a file. What if you need further processing? What if you need to understand the document to find the chemical content in it? So 2 use cases would be processing whatever you have internally so that it's not lost, it's auditable, it's searchable, or if you want to mine external documents like patents. So given a document like this, what would be nice if we could get structures like that? We have a tool for that. It's called document to structure, and it will do just that. So it can find serotonin and leucine and dopamine inside the document. What's even cooler is we have very, very useful metadata for all the structures. So it can give you the type of the structure. That's like the representation, the format. Is it a common name? Is it a systematic name? We can give you the page number, and we can give you context, which can be very, very useful in certain cases. Like here, it's not about leucine, it's about the X-ray coordinates of a leucine transporter. So very useful information. So if you want this, we can find IUPAC names, common names, INCHI, CAS, SMICE, anything that might appear inside the written document. We can also support your corporate IDs. So if you have a web service, if you have a database, you have a flat file that has CXN0001 is this SMICE, then we can work with that. We can find it in any document. We can also work with scan documents. So we have OCR with a very optimized error correction algorithm specifically for chemical names. So like ones and L's and I's are not the same thing. We can also call on optical structure recognition tools. So we support Clyde and Ultra and Imago very seamlessly inside all of these applications. So we can find the structures inside the images. So if you want this for a single document, then as I mentioned, you can do this with any of our tools, the simplest being Marvin View. So you just open up that PDF, even if it's a scanned PDF, the same way you would open up an SD file, which is pretty great. After some processing, you get a list of structures and some metadata. You can do this in JChem for Excel, Instant JChem, and Plexus as well. If you have even more data, if you want to create an indexed document archive, then we have a few different tools there as well. So we have document to database, which is like this toolkit. It creates a relational database out of all of your documents. Structures, documents, occurrences. We have Instant JChem to handle all of that data with very nice forms. And we have JChem for SharePoint, which has a very nice solution for this problem as well. Index all your documents so that you can search it. Let's look at the video. So we're going to check document to database, which has this demo site. You can play around with it. We have like a few weeks worth of USPTO patents, and we have some journal content as well. But for now, let's go with the patent database. So you have this standard search interface. Let's set up a query structure, something that might appear inside the document we're looking for. And we have the usual options to tweak some other chemical properties, like more weight. So let's set up between 500 and 700. Of course, we can tweak other search options as well, as usual. And we can change search types. So we have full coverage here. We can also filter the metadata that we have about the documents. So let's look at something that's been assigned to this OLED company. That's what we're working on. Once we submit, you get a list of structures. This is perhaps too much, so let's tweak the filter. Now it's looking better. We can work with this. And if you find something you're interested in, just click on it, and you get this patent description, where if you click on the patent ID, you get this annotated version of the document with all the chemical content in it highlighted. So we have a very strong product suite for English content coming from perhaps USPTO or the English part of European Patent Office. But what about other language content? So if you look at this chart, then compared to the previous 5 years, the number of patent applications in the Chinese Patent Office grew by 150%. And there is growth in the Japan Patent Office as well, although the patent claims are a bit bigger, so the number is a bit smaller. But still, we should do something about Chinese content, right? Well, we did. So we have Chinese name to structure, released about a year ago, and we've been refining it since then. We have OCR error correction for Chinese name to structure as well, and it works with systematic and common names as well. Furthermore, we added Japanese name to structure this May, and we have been refining it since then, and it too can work with systematic or common names. So we have a pretty good coverage of all the language content from the Patent Office, but we can go further if there is need. Just talk to us. Now, where does this all lead us? So there's been this long-standing problem in the IP industry when it came to content extraction. If you went with an automatic solution, then it was fast, but only a manual solution could give you the accuracy you need. Well, as a few others mentioned before me, we have this changed look on our Markush toolkit, and we are improving our naming toolkit constantly. So what we realized one day is that these two together form an extremely powerful combination. So with that, today, we are announcing ChemCurator, which is this semi-automatic or computer-assisted extraction tool. I'm going to give you a sneak preview, but there will be a full presentation with all the features and a demo tomorrow by RP. So here's how it looks. Just so you remember, on the right we have Markush editor, which is the editor I mentioned earlier as an integrated component. So it can give you the quality you need. And on the left, we have document to structure with the annotator that we saw in the video. That can dramatically speed up the extraction process for you. We also have structure checker there and project management and everything. And you can use this not just for patents, but you can use this for journals and all kinds of documents, any format, any language, any representation. You have the structures in less than a second, and you can manually curate what's wrong. So these are the folks you want to talk to after we're done here. That's Effie, Marvin product owner. We have Ákos for JChem for Office, Daniel working on the naming suite. We have RP working on ChemCurator, and Roland with the Biomolecule toolkit. And now we have Peter telling us how you can store and search all this data. Thank you.